You've got a robot in your hand. Now, it's time to bring it to life. But this is only possible if the model behind it understands its dynamics. Learning those dynamics directly in the real world is slow, costly, and sometimes dangerous. Instead, Sym2Real starts in simulation. Not a high-fidelity, fine-tuned simulator, just a simple one with its own default settings. From that, it extracts equations, compact, symbolic expressions that capture the underlying physics. Why? Because no matter the fidelity of the simulator, the fundamental physics stays roughly the same. No matter if a quadrotor is flying with different payloads, through various amount of winds, all share similar Newtonian structure. Our idea is to first extract that shared core. Symbolic regression gives us compact equations that generalize far beyond the training data. Think of a sine wave. A neural network fits the part it sees, but collapses outside its range. Symbolic regression recovers the true equation and keeps working everywhere else. That same principle holds in robotics. Even if a model only trains on forward driving, it still works in reverse. This generalization makes symbolic regression a strong base for adaptive control. But these equations alone can't handle the messy reality, things like sensor noise, motor delays, or extra weight. That's where the second step comes in. A small neural network acts as a residual, adding just enough correction to adapt the model in the real world. With this hybrid approach, a quadrotor can adapt to new payloads, unexpected winds, or shifts in balance, all with only a handful of real trajectories. The same method works for a small race car as well, coping with drifting or steering offsets. Unlike pure neural network approaches that need huge datasets, Sym2Real needs only a few runs, very few, yet keeps the structure of physics intact. And unlike pure symbolic models, it doesn't collapse when faced with noise. Together, the two sides combine, symbols for the core laws, residuals for the fine details. The result? Data-efficient, adaptive control, robust across simulation and reality, with little tuning and no expert priors. Sym2Real paves the way for robots to learn low-level control more easily, more reliably, and faster than before.